Hello, welcome back to my bench. If this is your first time here, hello, my name's Dave. I fix electronics down at the component level. Mostly I do ham radios and broadcast electronics gear. And if you're returning, welcome, hello. This way. I'm trying something new with cameras this time. I've been watching other guys how they do their stuff, and I've noticed that very few of them do videos from straight down. And the reason for that is a lot of the time you get to see the back of my head when I'm leaning over something. And I'm trying to limit that as much as possible. And the other reason is that when you're doing a straight down view, you don't have any perspective. It's just kind of like watching things on a flat plane. So I'm going to give this a shot and see how it works. And you guys tell me whether you like it this way or another way, the way I used to do it. Anyway, so what we have on the bench today is a compeller, an Aphex Compellor 300. We've seen these before on the channel. This one has a different kind of problem. The guy says that it is intermittent distortion on the left channel only, even when it's powered off. Now, that's kind of weird because these things are relay bypassed when they're off. The relays are on constantly when they're turned on and engaged, which I don't generally agree with, but I would rather have latching relays in there. But these little relays, I guess, are made for this sort of stuff. Anyhow, so if we look at the schematic here, let me bring it up for you. If we look at the schematic here, you'll notice that it comes in right here. I'll make it a little bigger. If I can. Okay, right here. It comes in right up here and goes through this stuff. A very high impedance input to an op amp and a bunch of other stuff, and it also comes down to this relay, which goes right back out. This is the output. This is the input. And he says that it's getting distorted all the time, or periodically. And I find it very hard to believe that any of this stuff up here could cause it, I guess, because it works fine. But we're going to check it out and see what we've got. I have a fair idea, but it might be a quick repair. Anyhow, so let's turn it on. It's running off of my my current limited power supply, the light bulb. I just switched it over to bypass because it does work. And it is on. Let's get the scope up here. Here's the scope, and you notice that if I tweak it just a little bit, nothing happens because it's not turned on. If I do this, now it's on, and you can see the output level. I can even them up, and the knobs are pretty darn close between the two inputs. This is A, this is B down here, and they're pretty close. So let's disengage it, and I've got it set up so that it doesn't do too much. You see a little bit of a flash there when I hit the switch, but that's a normal switch thing. And I'm going to do the first test that you do on all equipment. I'm going to bounce it. Nothing. Nothing. Okay. Well, that's called GE test procedure number 1, by the way. And it actually is a test procedure. In the old days, you had old radios that would go in cars. And those radios would have tubes in them. A lot of them were peanut tubes or sideways, laying sideways. And the tube sockets would go bad, bouncing around in the trunk of a car. And if it was working fine for you on the bench, you pick it up a half an inch and drop it and see if anything changed. At least that's what I've heard. So let's open her up. There we go. Anyhow, this is the insides. Got lots of LEDs and a few switches, transformer. This is the power supply. This thing has been recapped. So, you know, I'm not worried about the caps. I recapped it a couple of years ago. Well, let's see if we can tap around in here and see if we can get this output to change. So let's turn it on. Watch your scope. The jiggling that you see does not happen on a real scope. This is on the Handtech digital scope that goes in so you can see it on the screen. Anyhow, doesn't appear to be anything here. Whoops. Watch. I saw it do something. Yeah, see that little flash? There we go. All right, let's try this one on the other side. This is the B side. I'm hitting it the same amount. So, yeah. We're going to change that. I think I have. Yeah, I know I have one. So now it's turned off. It's not. It's just bypassing it. Oh yeah, look at that. Do this side over here. The B side doesn't do anything. So yeah, bad relay. Even the thing is unplugged because of the relay bypass. Look at it. Yep. Okay. Alrighty. Well, these are fun to take apart. First of all, you got to take the front off. Well, all the knobs first. Wow. Some of those are kind of stuck on there. Well, not too hard. Come on, there we go. Alright, now that you got the knobs pulled off, you have to pull the screws out of the front. It even says right in the front, a warning, remove faceplate and pot shaft nuts before lifting this PCB. Show you why in a minute. The noise you hear in the background is me trying to print something for the third time. 3D print something. If you can hear that, it's the fan on that thing's pretty noisy. Alright, so there's that guy. It is attached to the front. Nut removal. Was it this one? The big one? No, it's not the big one. It might be this one? Nope, okay. This one. Alright. Good. Just got to loosen these up. You don't have to take them off all the way. You do have to take these screws out. Here. Okay. And we have to take off, carefully take off these guys because they're nothing but headers. Cheap way of doing it, but I guess it's okay. It's very, a lot of stuff in a very small spot, so, alright. Now we have to take these guys off. And turn on the soldering iron. And the little one. Alright, now we can take this board out. That board's out. Now we got to take these guys out of here. I've done several of these. These and the 320s. 320 is a little bit different. It's approximately the same as far as the layout goes, but there's a little extra stuff to it. The 320D, the Compellor 320D, has a little board back here for the digital I/O, and that's the only difference between the 320D and the 320. But this is a 300. This one is older. Wow. That screw didn't want to come out of there. It liked it right where it was. I'm also going to work on presentation a little bit here, i.e. try to keep the desk clean. Alright, there. Now that board's out. These are very unique. That thing won't keep recording. I don't know what's wrong with it. These are very unique connectors, XLRs. They're actually screwed on from the bottom, which is weird. I've never seen any like that except in this thing. Alright, so let's get this off the bench. Give me a little room to work here. I do not know why that top camera decides not to stay on, but it's definitely not. Just a little action cam, and it's recording. I don't know. Maybe I'll get something off of it. I doubt it. Alright, so there's our little relay. It definitely has not been changed. Let's take it out. Best way to do that is give it a little globs of flux. There's one thing about this. This thing is going to be in my way. And I can keep hitting it with my arm. This might take a little more thinking on this. Some sort of a thing from above. Alright. I don't know. Yes, I know I should be using some sort of a fan. However, I've been doing this now for an awful long time. And, not dead yet. I don't breathe this stuff in. I blow it away. think I have to get my geek glasses on here, because I really can't see what I'm doing with a hoot. Yeah, if this is it, this will be great. Real quick little fix. Some of these things are a real pain. One of the things that these do is, I think one of the other videos I have show you wow. Alright. See if I can do this without ripping him off the board. Yeah, maybe. These things go through 3915s and 3914s like they were made out of water, which is a real pain in the neck. That's not working any better either. Suppose give them some better solder. The 3915s and 3914s are the LED drivers, and the way these work is 3915s drive one color of the front LEDs, and the 14s drive the other color of the LEDs. It's kind of interesting. Okay. Yeah, that's better. I'll tell you, I'm thinking maybe I ought to buy some stock in the company that makes this solder wick. I certainly use enough of it. But it is the most gentle way to get the to unsolder. There we go. Come on, stand up. They folded the pins over, of course, to hold them down. All right. Now we take a little You keep recording? No? Wiggle these around a little bit, see if we can get them off of here. Wow, I don't think so. I don't think so. Yeah. They're still stuck in there pretty good. They look like they're clear, but they most definitely are not. Well, it's a double-sided board, so you got to leave it on there long enough to get the solder off the other side, but don't leave it on there long enough to melt apart. That'll do it. And trust me, that can be a tricky little proposition. Neighbor's home. Wow. Trying to feel which one is locked in there so well. They all feel free. It's trying to come. Yeah, it's trying real hard. It looks like the pins are just really tight in those holes. You want to be careful. You don't want to rip the pads out on this side of the board. There we go. Yeah, they were just really, really tight. They look good, though. I mean, everything looks fine. All right. All right, I found them. Here they are. I did have, or I couldn't find, I've never been able to find these again. These are Aromats DS2E-S-DC5V. And Aromat, nobody carries them anymore. They're obsolete, it says. So, I've got a couple of these guys here. And these are Omron's G6A-274P-ST40-US5VDC. In other words, 5 volts. And the reason I ordered that one is because this is what's in the other side, except the other side's a 243, and it doesn't seem to be any difference between them. So the layout and the pins are the same. That's good. All right, let's clean this up just a little bit. They got some sort of a coating on the bottom of these boards that came from the factory this way that it just doesn't come off. It's gooey and sticky when you get it wet with isopropyl alcohol. But you can't get it off. It's stuck on there just forever. I guess it's fine considering these things are 40 years old and it's still working. So it worked for them, I guess. All right. Yeah, even that fit in there fairly tightly. And we resolder. Like I said, these things, this relay, I don't know if I said it or not, but the relays on these things, as long as you've got this thing turned on and engaged, working, the relay is on. And what happens to relays is when they're used regularly, they clean themselves. Most relays do. They're self-cleaning, and the way they do that is when the pieces come together, they'll come together and then slide a little. So you'll click and it slides a little, and then when it comes back to the other side, it's the other way. It goes click and slides a little, and that cleans the edge, the pads off on the relays. Relays will get dirty and go bad on you. I had a job once, not for very long, but I had this job fixing pinball machines and gambling machines. And they were on the south side of legal, let's put it that way. But and they were all hundreds and hundreds and hundreds of relays. And trust me, relays do go bad a lot. I replaced a lot of them. I'm telling you, those things, when you get out the schematic for one of those big old pinball machines, it covers an entire wall. I mean, 10 feet long, 8 feet high wall. And it's all interconnects. between relays. It's a pain, let me tell you. But hey, it was kind of a fun job, I guess. All right. Put things away. Try to stay neat if you can. All right, and let's get the box back up here. No way to test these things without putting them all back together again. All right. And here we are. So, put that back in. Get my standoffs. One thing I'm really surprised about with these guys, with these Aphexes, I mean, these boxes were not cheap by anybody's stretch of the imagination. And, you know, a few $1,000s. And they've got 25-cent, cheap as you can get, IC sockets in them, which is just, to me, it's just wrong. But, you know, I didn't build it. I just try to keep them going. This right one, yeah. I'm going to put it back together again, screws and everything, because I have great faith in my ability. Yeah, sure. All right. Pull you up so I can get to you. Pull you up. These are fun. Little flippy things. They're made so that under normal circumstances, if you want to fix this thing, you can just flip this board up. Well, not really, because this thing's attached. This one will get out of your way, but this thing's attached. You can't really flip it up. You can to a certain extent, but you can't. All of a lot of the signals go from one side to the other through this little cable. Also, this little cable gets broken in certain places depending on what you want to do. If you want to isolate left and right, if you want to get rid of some of the functions, you can cut pieces out of this cable. By instructions from the factory. All right, so put you back in here. Put you back in here. Okay. May as well screw these down. When I was working on computers, a while ago, we had this one motherboard that we used that came with a processor, and it said on the instructions for the motherboard, putting the processor in, it says insert processor harmoniously into socket. Harmoniously. That's a nice word. Some things do get lost in translation. Even Google screws things up. Sometimes I get some comments from folks who don't actually speak English at all, and some of them a lot of them that they don't do any English. I have to run over to Google and get it translated so that I can answer them. I try to answer all of my comments. If I get big, that probably won't be possible. All right. Now let's just put a screw in here for now to hold it. We can test it quickly. Put our ins and outs back in and out. I'm feeding this left and right with exactly the same signal. I just got a splitter cable back there. All right. So, here's the scope. Let us see how we do now. Yay. I'll guarantee you that did it. Plug it in, turn it on. Whoa. Wow. Evidently, there is a difference. What in the world's the difference? I went through these very, very carefully. Let's see. That is correct. That is the center. Wait a minute. I may have made a mistake. I thought I looked these up really carefully. All right, so goes this way. 8, 13, and 4 are correct. 4 goes to 6 normally closed, correct. 8 normally open, correct. 13, 11 normally closed. 9 normally open, correct. The relay is correct for its Oh. Did you guys catch that? Huh? Did you catch that right there? Let's put some power on the board. I bet it works better that way. Lord. Yeah. Some of you, I'm sure, were sitting back there giggling. How long is it going to take him to figure out he didn't plug the board in? All right. Click. Yay. And on. All right. Well, I adjust my inputs and outputs. All right. So we take this button over here. We push it out for program, which means what's actually going through the thing. We push it in for input. Both inputs are identical. They're both on 10. Well, minus 3 dB. We go for output. And here we want the knobs because you want them to line up. Turn the outputs all the way down. They fit rather tightly. Okay. Well, most of them do. Ooh, okay, there's that one. On an output, I don't care very much about the balance yet. Ooh, alright. Input. Try to line the knobs up. And another knob. Alright, so we'll take the input up to straight up. Let's see what we've got here. We've got, what are we sitting on? We're on input, we're sitting on 8 and 8. Alright, output, we're sitting on 0. Yeah, turn that down. Alright, so we want our output up to 0 dB. And our output up to 0 dB. Alright, and the inputs about the same. Okay, and these two guys are off. Let's look at the scope. It says what, 740 something. We hit the button. We got more dBs. That's interesting. that's 0, that's 0. Take my input, this input down. No, those are even. They're just very, 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 very touchy plots of inputs and outputs. So we got 10 in, 10 out, almost exactly. Well, -3 in, -3 out. And if we do this, that should drop it down, and that should slowly bring that channel back up again, doing what it's supposed to. It's a compressor. And if we do this one, it slowly brings it back up again. So it's doing exactly what it's supposed to do. And we don't have any more drop it out with this relay. Perfect. All right. Well, there you go. Now it goes on the burn-in bench for at least one day, and we'll see how it works. Hey, thanks. Okay, well, I'm going to come back in here for just a little bit and show you what we got as far as distortion on these channels. I just turned this thing on about 15 minutes ago, so it hasn't completely settled down yet. But on the distortion meter, tweak it about the best I can. It's right there. Right there. So we look at it, it's about 0.17, somewhere around there, for the left channel that he was complaining about, or what he said was giving him problems. Let's take the right channel off the scope. Oof, okay. And plug it in. And it's about 0.15, somewhere around there. So they're about even. I mean, the difference in different parts inside, but you're talking about 0.0 is nothing. So anyhow, so we're good. Now I'm just going to put it up on the burn-in bench and let it burn for a good long time. Make sure it's right. Hey, thanks for stopping by, and give it a thumbs up if you like the video, and don't forget to subscribe and hit that bell if you want to see why I'm doing more of this stuff. And don't forget, I got a Patreon channel over there, and I'm also up on Odyssey, ODYSEE. My videos are on Odyssey, but they go up on Patreon first. A couple of days they come over here, and if you'd like to support me and my little hobby, please feel free to go over to Patreon. Any amount that you want is fine. I appreciate any of it. It does get kind of expensive in here. So thanks for stopping by. Till next time.